Breaking news from Starbase. SpaceX has just completed a crucial milestone for Flight 7, the wet dress rehearsal that brings us one step closer to the next generation of Starship. The launch pad at Starbase is alive with activity as Ship 33, the first Block 2 Starship, stands ready for what could be SpaceX's most ambitious test flight yet. Welcome to Elon Musk 24 Hours. Today we're bringing you the full story behind Flight 7's preparations and the groundbreaking upgrades that make this launch different from anything we've seen before. On January 9, 2025, history was made when SpaceX rolled out Ship 33 to the launch pad. But this isn't just another Starship. With expanded propellant tanks holding 400 tons more fuel than its predecessors and standing as the tallest Starship configuration ever built, Block 2 represents a quantum leap in SpaceX's capabilities. Yesterday's successful wet dress rehearsal wasn't just a checkbox on a launch schedule. It was a full demonstration of every critical system working in perfect harmony, from the ground equipment to the fully fueled Booster 14 and Ship 33. With a launch window opening on January 13th at 11 p.m. Eastern, we're about to witness a test flight that could revolutionize our path to becoming a multiplanetary species. Let's dive right in. The story of Starship Flight 7 begins with a moment that captured the attention of everyone at Starbase. As dawn broke over the Texas coastline on January 9, 2025, the massive doors of the high bay slowly opened to reveal something unprecedented. Ship 33, gleaming in the morning sun, marked the dawn of a new era in spaceflight. This wasn't just another Starship prototype. This was the first Block 2 variant, representing years of engineering evolution and countless lessons learned from previous flights. Standing at an unprecedented height of 23 meters with its additional stainless steel ring, Ship 33 tells a story of continuous innovation. Every centimeter of this vessel carries the dreams and determination of thousands of engineers and technicians who have worked tirelessly to push the boundaries of what's possible. The expanded propellant tanks now hold an astounding 4,900 tons of fuel, 400 tons more than its predecessors, a seemingly small change that opens up entirely new possibilities for deep space exploration. Yesterday's wet dress rehearsal brought a palpable tension to Starbase. As liquid methane and oxygen flowed into both Booster 14 and Ship 33, the entire launch complex came alive with the symphony of modern spaceflight, the hiss of cryogenic fluids, the whir of pump machinery, and the steady countdown that echoed across the facility. This wasn't just a test, it was a dress rehearsal for a mission that could redefine our journey to the stars. But what makes Flight 7 truly revolutionary goes far beyond its impressive statistics. For the first time, we'll see SpaceX attempt something that's never been done before: the deployment of 10 mock Starlink version 3 satellites. While these aren't operational satellites, their release will validate crucial mechanisms that will one day help establish communication networks across the solar system. As they follow their suborbital trajectory before safely disintegrating in the atmosphere, each mock satellite will provide invaluable data about deployment dynamics in actual flight conditions. The enhanced heat shield on Ship 33 tells another compelling story of evolution through experience. Previous flights revealed the harsh realities of atmospheric re-entry, and engineers have responded with reinforced thermal protection systems strategically placed to protect crucial components. The positioning of the upper wings has been refined, creating a more stable flight profile during the critical moments of returning from the edge of space. Perhaps one of the most intriguing additions to Ship 33 are the thermal protection pins, seemingly simple components that carry enormous implications for the future. While they serve no structural purpose on Flight 7, these pins are pioneering technology that will eventually enable one of SpaceX's most ambitious goals: catching Starship in midair using the launch tower's chopstick arms. This capability, which might see its first attempt as soon as Flight 8, would revolutionize the rapid reusability that's essential for sustainable space travel. The next chapter in this story focuses on Booster 14, a marvel of engineering in its own right. The super heavy booster carries the weighty responsibility of not just lifting Ship 33 towards space, but also demonstrating controlled return capabilities. SpaceX has carefully planned two potential scenarios for the booster's return. In the optimal scenario, those massive chopstick arms at Starbase stand ready to attempt a catch, a maneuver that would showcase unprecedented precision in rocket recovery. However, safety remains paramount, and if conditions aren't perfect, Booster 14 will follow the Flight 6 precedent with a controlled splashdown in the Gulf of Mexico. The journey to Flight 7 hasn't been without its challenges. Each previous flight contributed crucial lessons that shaped the design and capabilities of Ship 33 and Booster 14. The team has meticulously analyzed every aspect of previous launches, from engine performance to aerodynamic behavior, incorporating these insights into the Block 2 design. This iterative process, while time-consuming, ensures that each flight pushes the boundaries of what's possible while maintaining the highest safety standards. Looking beyond Flight 7, the implications of this mission stretch far into the future of space exploration. The increased fuel capacity of Block 2 isn't just about reaching higher altitudes. It's about establishing the foundation for in-orbit refueling, a critical capability for future Mars missions. Every successful test of the thermal protection system brings us closer to reliable atmospheric re-entry on both Earth and Mars. Each deployment test validates mechanisms that will one day help establish human settlements on other worlds. Earlier today, we witnessed another testament to SpaceX's relentless progress. At 2:11 p.m. Eastern Standard Time, a Falcon 9 rocket soared from Cape Canaveral Space Force Station, carrying 21 Starlink satellites to orbit. This launch, the booster's 25th flight, set a new record for rocket reuse and demonstrated the maturity of SpaceX's reusability program. 13 of these satellites carry direct-to-cell capabilities, expanding the constellation's ability to provide global connectivity. The successful landing of this Falcon 9 booster on the drone ship, "Just read the instructions," serves as a powerful reminder of how far we've come in rocket reusability. As the Starlink constellation grows beyond 6,870 operational satellites, including approximately 400 with direct-to-cell capabilities, we're watching the infrastructure of tomorrow's connected world take shape in real time. Flight 7 represents more than just another test launch. It's a culmination of years of innovation, countless hours of engineering, and the unwavering vision of making humanity a multiplanetary species. As we count down to the launch window opening at 11 p.m. Eastern on January 13, 2025, we're not just preparing to watch a rocket launch. We're preparing to witness the next step in humanity's greatest adventure. This flight will test cutting-edge technologies that will enable future Mars missions, validate deployment systems that will expand our communication capabilities beyond Earth, and push the boundaries of reusable rocket technology. The success of Flight 7 will directly influence SpaceX's ambitious plans for 2025, including the groundbreaking goal of achieving the first propellant transfer between two Starships in orbit, a crucial milestone for deep space exploration. Each component of Ship 33, from its expanded fuel tanks to its thermal protection pins, represents a carefully considered step toward making space travel as routine as air travel. The Block 2 design isn't just an upgrade. It's a bridge between our current capabilities and the future we envision, where humans regularly travel between planets and establish permanent settlements beyond Earth. As we follow the journey of Flight 7, we're not just tracking another launch, we're witnessing the evolution of space technology in real time. The innovations being tested today will echo through generations, enabling achievements we can only begin to imagine. This is more than a test flight. It's a bold step toward making humanity's dreams of space exploration a reality. As we stand on the brink of this historic launch, Flight 7 represents more than just technological advancement. It embodies humanity's relentless drive to explore the unknown. From the enhanced propellant capacity of Block 2 to the pioneering thermal protection system, every innovation brings us closer to becoming a multiplanetary species. The success of Starship isn't just SpaceX's journey. It's our collective step toward the stars. Every test, every launch, and every landing writes a new chapter in human spaceflight. As we await the launch window on January 13th, we're not just witnessing history, we're part of the generation making interplanetary travel possible. Stay connected with Elon Musk 24 hours for real-time updates on Flight 7 and all future SpaceX developments. Join our growing community of space enthusiasts by hitting that subscribe button. We're on a mission to reach 65,000 subscribers, and your support makes a difference. Drop a comment below with your thoughts on Block 2's upgrades, and don't forget to share this video with fellow space enthusiasts who understand that the future of humanity lies among the stars. Thank you for being part of this incredible journey. Until next time, keep looking up. The next giant leap for humanity is just around the corner. In the relentless pursuit of fully reusable rockets, SpaceX has conquered challenge after challenge. But there's one final obstacle standing between them and their ultimate goal: the heat shield. These ceramic tiles, all 18,000 of them, have been the Achilles heel of reusability. Like delicate dinner plates strapped to a rocket experiencing intense vibrations, they're prone to cracking, expanding, and contracting under extreme temperatures. But Elon Musk just revealed something that's about to change everything. In a recent tweet that caught the attention of the entire aerospace community, he made a bold declaration: SpaceX will achieve a fully reusable heat shield by 2025, with the technology perfected by 2026. While some dismiss this as typical Musk optimism, those who've been following Starship's development closely noticed something different this time. Hidden in his November announcement was a crucial detail that points to a revolutionary shift in spacecraft thermal protection. The metal heat shield is making a comeback. Yes, you heard that right. SpaceX is reviving and revolutionizing a technology that NASA once explored, but never fully realized. With Flight 7 on the horizon and nearly 50 heat shield tiles mysteriously removed from Starship's surface, we're about to witness what could be the most significant breakthrough in spacecraft reusability since the Space Shuttle program. Welcome to Elon Musk 24 Hours. Let's dive right in. The story of spacecraft heat shields is written in scorch marks and sacrifice. Every successful mission, every safe return, has come at the cost of discarding expensive components. A price tag that's been accepted as the cost of reaching for the stars. But SpaceX has never been a company to accept conventional wisdom. To understand the magnitude of what SpaceX is attempting, we need to step back and look at what makes thermal protection so challenging. When a spacecraft re-enters Earth's atmosphere, it faces temperatures that would melt most metals. The air molecules hitting the vessel's surface create a plasma envelope hot enough to vaporize steel. This inferno of physics has been one of spaceflight's greatest challenges since the dawn of the space age. The current solution on Starship might look simple: 18,000 ceramic tiles covering its belly like scales on a dragon. But these aren't your ordinary kitchen tiles. Each one is a technological marvel, capable of withstanding temperatures that would turn sand to glass. Yet, as Elon Musk pointed out with characteristic frankness, you've got a whole bunch of dinner plates stuck on the side of a rocket that's shaking like hell. It's not just the heat they have to contend with, it's the violent vibrations, the extreme temperature swings, and the physical stress of atmospheric re-entry. The ceramic tiles are remarkably similar to those used on NASA's Space Shuttle, but with one crucial difference. The shuttle's tiles were custom-shaped for each specific location on the vehicle, a meticulous approach that meant replacing even a single damaged tile could take months. SpaceX revolutionized this by creating standardized hexagonal tiles, making manufacturing and replacement far more efficient. But efficiency isn't enough when you're aiming for rapid reusability. This brings us to Flight 7, where SpaceX is making a bold move that's raised eyebrows across the aerospace industry. Nearly 50 heat shield tiles have been removed from Starship's surface. To the untrained eye, it might look like a step backward, but those who've been following SpaceX's development know better. This could be the first test of something revolutionary. Enter the metal heat shield, a concept that sounds counterintuitive at first. How can metal, which can melt, protect against temperatures hot enough to melt metal? The answer lies in one of the most ingenious cooling systems ever devised for spaceflight. Back in 2018, Musk first hinted at this technology, describing what he called a stainless steel sandwich. Picture 2 layers of steel with a network of tiny channels between them, almost like the blood vessels in your body. Through these channels would flow either fuel or water, creating what engineers call a transpiration cooling system. As the liquid seeps through microscopic perforations in the outer layer, it creates a protective barrier against the intense heat of re-entry. But SpaceX isn't the first to explore metal heat shields. In the 1990s, NASA and Lockheed Martin were developing something remarkably similar for the X-33 Venture Star program. Their design used a sophisticated honeycomb structure